Assalamu alaikum, welcome to Mr. Engineer YouTube channel. In this video, we will talk about most important electrical engineering MCQs part 5 with explanations. If you are not subscribed my YouTube channel, kindly subscribe my YouTube channel, stay up to date with the latest information and technology. So let's start. Our today's MCQs is power in an AC circuit is found by Vi sin theta, Vi tan theta, Vi cos theta, Vi. So our right option is option C, Vi cos theta. The power in an AC circuit can be found by multiplying the voltage and current I in the circuit. However, in an AC circuit, the voltage and current can vary over time. So the power will also vary. The formula of calculating the power in an AC circuit is P is equal to Vi cos theta. So correct option is option C, Vi cos theta. The power in an AC circuit can be found by the multiplying the voltage V and the current I in the circuit. However, in an AC circuit, the voltage and current can vary over time, so the power will also vary. The formula of calculating the power in an AC circuit P is equal to Vi cos theta. Our next MCQ is modulation index in amplitude modulation. Option A is defined as the measure or extent of amplitude variation about an unmodulated carrier. Option B does not impact power distribution. Option C is independent of integral multiple of amplitude. Option D, none of these. So correct option is option A, because the modulation index also has an impact on power distributed in the transmitter. The modulation index also has an impact on power distribution in the transmitter. As the modulation index increases, the power distribution in the transmitter also increases, which can affect the efficiency of the transmitter. The modulation index is dependent on the integral multiple of amplitude, and it is often expressed as a percentage or decimal value. Therefore, the correct answer is option A. The modulation index is defined as the measure or extent of amplitude variation about an unmodulated carrier. So today our next MCQ is Fourier series are infinite series of elementary trigonometric function. Sine n, option A cosine, option B sec, option C cosec, option D tan. So correct option is the basic idea of the Fourier series is that any periodic function can be represented as a sum of sine and cosine functions with appropriate amplitude and frequencies. The frequency of these sine and cosine functions are integer multiple of the fundamental frequency, which is the reciprocal of the period of the function. Therefore, the correct answer is option A cosine. Our next MCQ is an SCR silicon control rectifier goes into saturation. The gate cathode junction is option A forward bias, option B reverse bias, option C in steady state, option D polarized. So correct option is forward bias, because an SCR is a type of thyristor that is commonly used as a switch in electronic circuit. It has three terminals, an anode, a cathode and a gate. When a positive voltage is applied to the gate with respect to the cathode, the SCR becomes forward bias and can start conducting current. Once the SCR starts conducting current, it remains conducting even if the voltage across the anode and cathode is reduced at a lower level, until the current through the SCR falls below a certain value. So our next MCQ is dropout to cutoff ratio for most relays is of order of 0.2 to 0.3, 0.3 to 0.4, 10.4 to 0.6, 0.6 to 1.0. So our correct option is option A 0.2 to 0.3, because for most relays the dropout to cutoff ratio is of order of 0.2 to 0.3. This means that the level at which the relay drops out is typically 20 to 30% lower than the level at which it switches on. Therefore, the correct answer is option A. The dropout to cutoff ratio for most relays is of order of 0.2 to 0.3. Option B, C and D are not correct, as the dropout to cutoff ratio for most relays is typically lower than 0.4.